Hey guys, welcome to this Go tutorial. Before we start, say a couple of things about Go. It's a language that might look familiar initially if you're a C programmer, but there are quite a lot of differences. Obviously the most important one being that it's a garbage collected language, which means that you don't have to worry a lot about memory management. And allocating and deallocating memory. Another difference you might say is that it's got built-in runtime type information for all its variables, and you can query the type of variables and inspect them as part of the actual code and see what you do, and make different decisions based on that. But let's start at the beginning and have a quick look at how to declare variables. First of all, I've got a little example here, and you can see that we've got a main function here. That's a bit like C. Main is the first function that gets executed in a Go program. And here we are. We're going to define a variable called name, which is of type string. So that's a bit strange for some people, maybe, that we've got the name first and the type second. Here we're assigning a string literal called Alice into the variable name, and the blasted IDE is complaining at me, as you can imagine, that I should have stuck those together on one line like this. This one declares the variable and assigns it at the same time, and the type is inferred here. So this is a pretty neat feature of Go. Since it knows that this thing here is a string, it doesn't need to be told the other name is a string, you see, so you can just assign to it straight away without the type. And here is an expression version of that statement using the colon equals operator, and that declares and assigns something, and it just is a useful expression because you can fit it into some control flow situations that will let you, that are convenient. Anyway, Go is a pain in the neck sometimes. It demands that you use all your variables that you declare. So here we have a print statement to make sure that they get used. And you notice it's printf. Hooray for printf. It's a much easier to use printf than you get in C. Firstly, you can see that it's in this package called format, FMT. And just to show you the top of the program, up here at the top of the program, we imported the format module so that we could use it. And down here, we're looking into the format module and calling the printf function that's inside it. And all we have, I keep zooming down too far. This is the one we're looking at, yeah. So in this printf, we're printing out the names that we declared up here, and we're using a very much simplified version of the C format string, where there are only a couple of different things you can put in here. And %q means print the value that you see on the first parameter, but put quotes around it when you print it. And it's really clever because it doesn't really need to know what type this thing is. It doesn't need to know that name is a string, because printf is able to look at the type of the variable when it gets called and say, it's a string, so I must print it out as a string. So it's a lot easier than using printf in C. What other types do you have? Well, quite a lot, but these are a couple of the main ones. You've got numbers, and you've got integers and 32-bit integers and unsigned integers and all that kind of stuff. And you've got booleans, and this is what it looks like to assign to booleans. So false with lowercase false and lowercase true. And here again we have to print those out. And here you see some changes. %v just means print something out without putting quotes on it. %d means something is definitely a number, and that allows me to put in number formatting commands to say that all the numbers must be 2 characters wide or whatever. And down here Oh, and down here we have the next exciting thing, which is a structure. Where does this structure get defined? Oops, it's a person structure that's being assigned to variable Bob. Where's person? Well, I was cheating and I hid it up here when we started. So here's a person. We're defining a type person struct, and it's got a name and an age field. And if we go down back to where we were in declaring one of these, you can see that you're able to specify the field name for each value. So we said we've got a person, and inside there's a name and an age, just like in the definition. And here, of course, we're printing it out. By the way, let's go and look at the printout, because I've got it all at the bottom here. I've already just run it a moment ago. Here we're printing out the names. Yes, that was up here. So, and they've got quotes around them because of the %q. And here we've got a boolean. You can see the type system is smart enough to see that this is valid, that's passed in as a parameter, as a boolean, and it prints up the string true for that. But for the numbers, it prints out other things, and they don't, I think, have the formatting so that I added in these little formatting commands. So they've just got number equals 0. Let's see what happens when we run that again. Ah, yeah, you see there's a little space here now in front of the 0 because we told it %2d. So he said pad it out to two positions, 2 columns. Anyway, okay, and here we defined our person Bob, whose age is 24. Another very different and interesting thing, basic thing about Go, which saves a lot of trouble, is that variables are always initialized to then what is considered their nil value or null value by default. So, for example, a string's nil value is, an empty string. For an integer, 0 is the nil value. For a boolean, false is the nil value. And so I can create a person instance, an instance of the person struct, and assign it to this variable called nobody, and this will have an initialized name and age. And if you print that out here, what you see is that you get a blank string and a 0. And I would also just point out quickly here, what's rather clever is that here I passed in the whole structure, and the printf command was able to use the type runtime type information to investigate that structure and figure out what fields it had and print them out correctly, even though I'd never seen them anywhere before. Oh, excuse me 1 second. Right, so that was nobody. That was an uninitialized structure. So the next thing we can show you is that we have pointers in Golang, and here we have a pointer pointing to this very structure that we declared earlier, and we're saying that person pointer is going to point to Bob. And another great difference with C and C++ is that you cannot do pointer arithmetic. So I cannot point to Bob plus 1 to the next Bob, or if there was an array, for example, I couldn't point to the next one by adding 1 to the pointer. That's totally illegal, and that saves you from very great number of problems, but it still lets you do passing by reference, which is pretty important. And here we are, we're printing out that pointer. Interesting. How do you print out a pointer? Well, down here you can see what a printed out pointer looks like. Again, because of runtime type information, printf is able to go in there and see, I've got a pointer, and I can dereference it and go and print the fields that are inside that structure. And it just puts a little ampersand there to tell you that it's a pointer. And then the next statement here, we are dereferencing the pointer before we send it to printf. So we're sending a structure by value to printf, and it just gets printed out very similarly, but without the ampersand. You can print a null pointer, so that's that's pretty reasonable. It won't crash. It'll just print out this complicated thing here, which tells you that it's printing out a null pointer of type person. Here I'm defining, I'm using an anonymous, I'm creating an anonymous function that returns an integer. And here you can see this is the type signature part that tells you it returns an integer, and I'm just returning 1 there, and I'm assigning this to a variable that I'm going to use later. But it's just worth noting that functions can be passed around as arguments to functions and to other functions and so on, just like a variable can be passed around. Okay, so let's scroll down. Now, next thing, arrays. Okay, an array is declared by putting the type of what the array is going to be. So in this case, a person structure, and then in front of that you put how big the array has got to be, 2 elements in this case, and you put that inside open close brackets. So here we are declaring a variable named team, and we are assigning a literal array to it, which we've defined here, which is 2 person objects. And the 2 person objects are Bob. We created Bob a bit further up. Here's Bob at the top here. We defined him up here. That's number 1. The 0th element in the array is Bob, and the second element in the array is Alice. And here we have to print that out, and just to show you how you access elements in an array, it's just like that, as you might expect. It's worth noting something here, I think. Maybe you're starting to wonder why I have name with a capital letter, start with a capital letter. Well, that's because Go's way of hiding information is that variables and types that start with a capital letter are visible to other packages, and variables and types and functions as well that start with a lowercase letter are not visible outside the current package. So in this particular file that we've got here, main.go, belongs in the main package, and anything else that's in the main package of this program is going to be able to access functions and variables in it, like this structure. But if I had named this with a lowercase p, then other packages that are outside couldn't import this module and access the person structure. They wouldn't be able to. Or they would, if I'd named this as lowercase n, then they wouldn't be able to access the name field. So capitals are actually important with names. They control whether a name is exported outside the current package. So I just thought I'd point that out. That's it helps to explain, and that's why you can see, for example, when you've got a printf here, it's in the format package and it starts with a capital P. That means it's exported from the format module, sorry. And so if it had been named with a lowercase p, I wouldn't have been able to use it. Okay. So we've declared an array here, and we've printed out something from the array. That's good. We've accessed an element. But this kind of this thing where you have to say how big the array is going to be is a bit of a drag. Quite often, you want to declare an array and you just want to add new elements into it without having to, have to keep going back and sticking in the right, increasing the size. So you can use ellipsis instead, and so here we've got a multi-line array declaration, and we haven't bothered to say how many elements the array has got in it. The compiler will figure that out from looking at how many records we put in this literal. And so we've got, and here I'm demonstrating the fact that you don't need to use the field names but you can if you want to. And it just depends on what's clearer. Notice the comma at the end of this list of this array. That's always something you need to have. And notice here too again that I made a mistake there. Control Z. Okay, I'm just printing this array out. I don't have to print out each record individually. I don't have to each index. I don't have to print it out individually. I can just print the whole thing, and the printf function will have a way to print an array, that is somewhat reasonable, and will give you some, and it saves a great deal of trouble if all you want to do is debug something or whatever, and you don't want it to format it in some fancy way. But in practice, we almost never use arrays directly, or at least I never have. We are almost all the time using a thing called a slice, which is an interesting concept. It's a view onto an array. It's like a position in the array plus a length. And arrays are immutable, but slices can grow and contract and can be made to look at different parts of an underlying array. And so the way you declare a slice is that it looks exactly like an array, but it has nothing in the brackets here to indicate how many elements it's got, and so that's how the compiler knows that this is going to be a slice. And I can make a slice point at an array, or a view, or be a window onto different parts of an array, like this, by using this syntax, which would be familiar to somebody who's used Python or some other languages. So that means that we're going to point, this team slice is going to be a view onto the other team array that excludes the 0th element, but it's going to include all the others. And if you look down here, let's just scroll here. The full array is, we printed it out, is Jane, Fred and John. And if we take this first one, where we're choosing every element except the 0th one, then what you get is, instead of just Fred and John, because we cut Jane off, this next one is all elements except the last element. So we're taking the length of the array and minusing 1 to make sure that we cut off the last element, and we're starting from 0. This is what that little, not when you don't bother to put a number in there, it means from the beginning. And so here what we can see is when we print that out, we're left with Jane and Fred, which is correct because we're excluding the last item, which was John. So that's what that one is doing. And here we have a slice which is extracting something from the middle, and in this case it extracts John from the middle of the array. So having created this slice, team slice, it looks like an array, but it is referencing the values that are in other team. Okay, so the next lesson is going to be control flow statements, or flow control statements, I don't know, but we'll do that then. Cheers.